Assalamu alaikum student. Today we discuss the topic that is the RL series circuit. To discuss the RL series circuit, first we draw the diagram. Here we draw the diagram of RL series circuit in which we take the resistor in series of the inductor and apply the source voltage V. Here we connect the resistor R in series with the inductor L and apply the voltage V. So here we write about this diagram, that is the consider a resistor R and inductor L connected in series to a source of alternating voltage V as shown in diagram. Okay, what happened when we apply the source in the circuit element resistor R and inductor L? When applied voltage across the circuit, the same current will flow because of the resistor and inductor. Both are connected in series. So here we write that when an alternating current, when an alternating voltage, when an alternating voltage is applied, then the same current would flow each of them because the resistor R and inductor L are connected in series. Inductor L and resistance R are connected in series. Whenever we connect the resistor R and inductor L in series, same current flow both of them because both are in series. Then now we write about the what is the voltage across the resistor R. Voltage across the resistor R when the current is flowing through them is VR is equal to IR according to Ohm law, and voltage across the inductor that is equal to VL I XL. XL that is shows the inductive reactance. So here we write that voltage across resistance R R that is the VR is equal to IR. Similarly, voltage across the inductor L, voltage across inductor L is that is equal to VL is equal to IXL. VL that is equal to IXL. XL that is shows the resistance of opposition offered by the inductor. L that is shows by the XL that is called the inductive reactance. Ali takes Saya. Hi to welcome to my class. Thank you so much for watching. Okay. Now we discuss the next topic, that is the voltage and current are in phase. Okay, we know that across the resistor the voltage and current are in phase. In case of resistor are voltage and current are in phase. In the last lecture, it is already discussed that the voltage and current both are in phase. This is the direction of the voltage. So, voltage of the current is also in the same direction of the voltage. Both are in phase. Second, we discuss about the inductor. We know that in the inductor, the voltage lead the current by 90 degree. In case of inductor L, voltage lead current by 90 degree. So if we take the current in the reference horizontal axis, so we know that the voltage lead the current by 90 degree. So here is the voltage of inductor that is lead the current by 90 degree. This is the voltage of resistor, so it is denoted by VR. Okay. Next we find the resultant voltage. How we find the resultant voltage? Okay. For find the resultant voltage, taking the current as the reference phasor, taking the current as the reference phasor. When we take the current as the reference phasor, so we both draw the phasor diagram across inductor and as well as resistor. This is the reference axis that is shows the current. We know that in case of resistor, voltage across the resistor in phase of the current, and the across the inductor, voltage lead the current by 90 degrees. So here we draw the voltage across the inductor lead the current by 90 degree. Here we add them by head to tail rule. So here we find the resultant voltage, that is shows the applied voltage apply across the inductor and resistor. So here we find the resultant voltage. Okay, here taking the current has the reference phasor. The voltage we are in phase with current. The voltage we are in phase the current. The voltage VR, that is lead the current by 90 degree. So here we write that the voltage VL lead the current by 90 degree. So by head to tail rule we can find the resultant applied voltage V by head to tail rule. We can find the resultant applied voltage V. Okay, we find the resultant voltage applied V. Here we use this marker, write that. Okay, this is the formula to find the resultant voltage. Taking the square of the voltage of resistor plus voltage across the inductor and then take the square root, we can find the resultant of these voltage. Okay, by Ohm law VR that is equal to IR square plus VL that is equal to IXL in the resistance. In case of inductor we show the resistance by XL, that is shows the inductive reactance. That is we discussed in the last lecture when we discuss about the inductor. Here we can find the R square plus XL whole square. This combined effect is opposition offered to the flow of current is known as the impedance. This is the impedance that is offered the combined opposition to the flow of the current. Impedance always shows by Z. So formula become V is equal to I Z. So impedance can be found by if we know the voltage and current. Z is equal to V over I. That is the formula of the impedance. Impedance that is shows the combined opposition offered to the flow of the current. Next we discuss about the definition of the impedance. If you want to take the screenshot, save them, then we move to the next topic, that is the impedance. What is the impedance? Okay, last we find the resultant voltage. We find the resultant voltage that is equal to V is equal to I under root R square plus L square, and we find that this value is known as the impedance. Impedance that is shows by Z under root R square plus L square. Impedance is the combined opposition offered to the flow of current. Combined opposition offered to flow of current. So, and we write that is V is equal to IZ, that is the impedance, and we can find the impedance if we know the value of voltage and current, that is equal to Z is equal to V over I, that is the impedance of the RL series circuit. Now we write the definition of the impedance. Has the resistance R and inductor or capacitor offer opposition to the flow of current. Offer opposition. साले काट के offer opposition to the flow of alternating current. Okay, we know that their combined opposition offer their combined opposition offered to the flow of current is known as impedance. Impedance that is shows by Z. This is the definition of the impedance. Okay, next we discuss about the phase angle. What is the phase angle? First we draw the phasor diagram, then we discuss about the phase angle. What is the phase angle? Here we draw the phasor diagram. What is the phasor diagram? In the reference axis we take the current, and we know that the voltage is in phase with the current across the resistor, and across the inductor voltage is make an angle of 90 degree. F So the applied voltage V, that is resultant voltage, make an angle of phi. So here we write that the phasor diagram show that the phasor diagram shows that the current lag behind the voltage, the current lag behind the applied voltage V by an angle phi. The angle phi can be determined by phasor diagram. The value of angle phi can be determined by phasor diagram. Okay. In the phasor diagram, the angle phi can be found by tan of phi is equal to VL over VR, and we know that VL, that is equal to I XL, and VR is equal to I R. So tan phi, that is equal to XL over R. So this is the formula we can use to find the phase angle if we know the inductive reactance and resistance R. So we can find the phase angle. So this is all about the phase angle. What is the phase angle? The combined current flow to the inductor and resistor R. The current is always lag behind the voltage by an angle phi. So this is the angle phi. Okay, this is all about, we discuss about the resultant voltage, impedance, and then phase angle. Okay, our next topic, that is the power cross RL series circuit. And then we also discuss about the wave diagram. A wave diagram discusses also two topics left behind. One is power and second is if you like my video, please like, subscribe and shares my video. Thank you so much for your watching. In the next class, we discuss the power in RL series circuit. What is the power in RL series circuit? And also discuss the wave diagram of the current and voltage. Power and AC circuit. The expression for power is volt when voltage and the circuit is pure resistor. Shape your inductor into a crystal circuit in case current layer or limit the apply voltage inductor and then component of applied voltage along with current I is 0.